An ellipse is an oval curve that looks like an elongated circle. An ellipse is a set of all points in the plane, the sum of whose distances from two fixed points called foci. So what we're going to do is we're going to look at an ellipse centered at the origin first, and there's two different kinds. We have one that's more longer, running left to right, and one that's more taller, running top to bottom. The first one we're going to look at here is the one that is longer, from left to right. So zoom out so we can see it and all the parts to it. So here we have the first one. We have the equation x squared over a squared plus y squared over b squared equals 1. The equation of ellipse is always equal to 1. If it's not equal to 1, then it's not in the correct form. An ellipse that runs longer, like this, from left to right, will have the bigger value a under x and the smaller value b under y. That way you can tell which way it is, lengthwise, whether it's longer or taller. If the bigger number is under x, it's longer. The vertices, right here, plus or minus a comma 0, are on the major axis or the longer axis. So right here, these points here, a and negative a, are the vertices because they're on the longer part of the ellipse. The major axis runs horizontally because this is a horizontal ellipse because it runs left to right with a length that's 2 times a. And the minor axis, this part here that runs vertically, is the minor axis that's length 2 times b. The foci, plus or minus c, that here is in green, are located here and here on an ellipse. And you're typically not given c from this equation up here, as you can see, but you can get a and b. To get c, you get it from this equation here. C squared equals a squared minus b squared. And it is a squared minus b squared, not plus. Plugging it in here to this and solving for c will get you c for the foci, here and here. Second, we have the vertical ellipse, the one that runs longer up and down. So zoom out so we can see the whole thing. And it has the similar equation, except you can see that a is now under y and b is now under x. So if the bigger number is under y, then it is a vertical ellipse that runs longer, or is more taller, up and down like this, versus the other one, which was longer left to right. It also has vertices, but instead of it a and 0, it's 0a. Again, it's on the major axis, the longest part of the ellipse, here and here. And its major axis, again, vertical, as is the ellipse, with a length of 2 times a. So you can get the distance just 2 times a. The minor axis runs horizontally right here, as is the smaller part of it, has a length of 2 times b. And the foci, similar to what we did before, is 0 comma plus minus c, this time with the c being in the y value. And you can get the c value by doing the exact same equation, c squared equals a squared minus b squared. So these are the two kinds of ellipses you can expect to run into when they're centered at 0, this easiest kind. Now, there's some more that goes with ellipse, and that's called eccentricity. The eccentricity of a conic section is a non-negative real number that uniquely characterizes the shape. The eccentricity E, and is not to be confused with Euler's number E. The eccentricity E of every ellipse satisfies the following, where E is between 0 and 1. And just to know that an eccentricity is a number, and you can get it by taking C and dividing it by A. So you can get the eccentricity of an ellipse by just taking C and dividing it by A every time. Now, when E, the eccentricity, is closer to 0, the shape of the ellipse is going to look more like a circle. Whereas if the eccentricity E is closer to 1, the shape is going to be longer and thinner. So the eccentricity can dictate the shape of the ellipse itself. And again, you find that by taking C and dividing it by A. But you can also shift ellipses. And so here are the two shifted ellipses, vertical and horizontal. and their equations. So the first one here is the horizontal that's centered at h and k, and you can get it from this equation here, x minus h squared over a squared plus y minus k squared over b squared equals 1. Again, it has to be set equal to 1. And your h and k value, kind of similar to a circle, is your center. And you can get the other points A, B, and C, or the foci, the vertices, the points around so you can draw the ellipse better, by just simply adding h and k to the parts that it is normally at when it's centered at 0. That way, instead of trying to find where it is, just know where it is centered at 0, then add your h and k to each part to find out where it has been shifted to. Same thing with the vertical ellipse. This time, A is under Y and B is under X. So this is, again, you can tell it is a vertical ellipse. Again, H and K are your center, just like a circle. But your vertices and foci, just add your H and K as if it was centered at 0 to find out where it has been shifted to. And that's how you would work with an ellipse centered at 0, find its eccentricity, and working with shifted ellipsi.